For our second topic this week, we're going to discuss the ways that geospatial technologies are prevalent in our lives today. Just to remind you, the learning outcomes for this week include that students will recognize and describe how spatial concepts are relevant to the study of human geography, and that students will recognize and describe how geospatial technologies are present within and contribute to everyday life and decision-making. The use of location-based functionality and services is increasingly prevalent. A huge amount of information in our world is becoming location-enabled, and that means we are using our cell phones and other mobile devices, such as GPS units, to interact with and display the geographic information in our world. We often lump all location capabilities together as having a connection to GPS, the Global Positioning System, that the U.S. launched a few decades ago, with its orbiting series of satellites. The GPS was started in the late 1970s by the Department of Defense, and it has been fully operational since 1994. At this point, it's still the world's most widely used system, but it's only one of many Global Navigation Satellite Systems, or GNSS. 3 of the other systems under development now include the Russian GLONASS system, the European Galileo system, and the Chinese Beidou regional system. In the next few decades, depending on economics, these systems, and another being launched by India, will far outpace the aging U.S. system. Every GNSS works the same way to pinpoint locations on Earth, and it's based on where the signals received by the satellites overlap and intersect. It's a process called trilateration. But in fact, much of our locational triangulation these days happens through the ground-based systems of cell phone towers and wireless internet routers. However, it's all based on the same spatial mathematical relationship of knowing exactly how fast a signal takes to move and knowing how far the distance that signal has traveled from its particular starting point to where you are located. So, trilateration is the process of determining absolute or relative locations of points by measurement of distances, using the geometry of circles or spheres. In contrast to triangulation, trilateration involves measuring distances rather than angles. Here's an example. Let's say that 3 different people are driving to the same destination. Their destination is Grandma's house for Thanksgiving. We don't know exactly where Grandma's house is, but we do know the place from where each person started driving, and we know how fast everyone will be driving. The first person starts at the red dot and drives in a straight line at 60 miles per hour for 10 hours, or 600 miles. So, after 10 hours of driving, they could be anywhere on the outer edge of this circle. The second person starts at the blue dot and also drives in a straight line at 60 miles per hour for 4 hours, going 240 miles. So they would be somewhere on the edge of their blue circle. This means that the common destination must be on one of the 2 green dots, the only 2 places where the 2 travelers would both have reached by the end of their travel time. The third person starts at the orange dot and also drives in a straight line at 60 miles per hour for 1 hour, 60 miles. So they could have traveled out to the edge of their orange circle, a 60-mile radius. But since all 3 people have reached the same destination at the end of their travel time, they can all only be at one place where all of their travel circles overlap, which is the green circle. The same system is how we can use the signals from satellites to figure out where something is on the surface of the Earth. In that case, the green circle, formerly known as Grandma's house, is where we are sitting with our location-enabled cell phones. When we ask the phone to tell us our location, it receives signals from satellites whose exact locations are precisely known. And since it knows how fast those signals have been traveling, it can calculate the locations that could have been reached in that amount of time. Voila, Grandma's house. Here are some pictures that tell the same story. The area that 1 satellite could reach, 2 satellites, and 3 satellites. This pinpoints the location. Cell phone towers are going up like crazy these days, and they're the fastest growing system of location-based information. OpenSignal is a website that provides current information on cell coverage and gives recommendations for phone carriers. You can put in your location, your city or your zip code, and it will generate a map for you that shows the relative strength of cell phone signals. You can also use it to see the current locations of towers themselves, including the fake ones that are designed to look like fake trees. Failed attempts to blend in. These images were taken by photographer Robert Voigt, who clearly also finds them amusing. Why do cell phones matter so much? Because they've become the universal device. The rapid growth of cell phone usage in India, among other places, is often in the news. In India, cell phones are more prevalent than houses with indoor plumbing. What else was interesting about this story? That learning about the cell phone usage was a byproduct of the Indian census done every decade, which they had to do with satellite imagery, because using printed maps to find households in quickly growing slum neighborhoods doesn't work. Right now, not every cell phone is location enabled. That is, not every device has the built-in technology to be able to tell you its own location. iPhones are location enabled, and this was big news about a year ago when people learned or became aware of this. By default, your own iPhone device records its own location unless you disable it. This is a map that was made in 2011 of someone's travel log. The bigger the circles, the more time spent in that one area. What this really shows is which cell phone towers were near that person's phone and helped to transfer the phone signals. What are some of the professional, personal, and consumer applications of all of this location technology? On the professional side, there are whole new ways to do old jobs. Have you heard the statistic that a very big proportion of our young students will have jobs in their lifetime that don't even exist today? 25 years ago, precision agriculture was one of those fields. According to a crowdsourced encyclopedia, precision farming or precision agriculture is a farming management concept based on observing and responding to intra-field variations. It relies on new technologies like satellite, imagery, information technology, and geospatial tools. It's also aided by farmers' ability to locate their precise position in a field. It has also aided the farmer's ability to locate their precise position in a field using the GPS system. So it means that farmers can gather information at very precise locations, usually while on a tractor with GPS devices attached, from within a particular field, and adjust or micro-target their application of fertilizer or pesticides or irrigation. The control can be varied down to the level of inches. Many farmers in the world don't have access to such technology, but it is a force affecting their livelihood because those who do have higher yields, lower costs, and create less polluted runoff. Another field that didn't exist in the same way before? Location-based micro-advertising. Because of the way that we share information about our location and our activities, and the way that those are monitored by other companies, retail-based companies can learn exactly where people are likely to be, who are the types of people who are likely to want a particular good or service. Whatever your message is, you can advertise it on a poster or on a lamp post located right where your desired audience is likely to see it. On the consumer-driven side of this, location and geography are convenient ways to search for goods and services. A zip code is one of the easiest ways to generally describe a location. So databases of information, like a big list of quality dentists, are now searchable based on their zip codes or proximity to that zip code. There are hundreds, if not thousands, of examples like this on the web. Looking for a pet to adopt? You can find ones that are available to be adopted near you. At the same site, you can find a shelter near you if you need to take a dog or cat that you found. Location makes a lot of sense for social services too. like finding friends or finding people that you want to be your friends. Location-based services and dating apps are big business these days. Then there's the location information we volunteer, like when we sign up for those preferred shopper cards at the grocery store or any other chains. The stores don't really care about the 25 cents you save on your yogurt. They really do care about the targeted advertising they can do, or how they can sell your information to companies that collect consumer expenditure data. That's how business analytics work. Down to the street level, if you're willing to pay for the data. You can learn what magazines people subscribe to, how frequently they go out to eat, and whether they like high-end coffee drinks or not. So this is the location data about ourselves that we're often not aware that we're sharing, even though we were the ones who started it by allowing a store to connect our names with our addresses, and then letting them know how much yogurt and lattes we buy every time we swipe one of our cards and save money. There's also a type of geographic information that we don't think so much about sharing. That's that which is collected often without our knowledge. For example, if you put your individual computer's IP address into a website called InfoSniper, it will tell you where the computer is located that just accessed that website. So if someone knows your IP address, they can tell you where your computer is, more or less. One example of using location as a game was designed by folks at the University of Virginia. It's a simulation game that lets you explore the impacts of decisions about land use and other policies on the sustainability of the watersheds that flow into the Chesapeake Bay. It was originally designed as part of a local citizen and college student exercise, but now a version is being created for K-12 students too. The combination of citizenship and games, supported by location information and geospatial technologies, is very powerful. Really, maps and geography are everywhere, when you become observant. Challenge yourself to go one day of listening to the news without coming across a story affected by geography or maps. Model for your students what it means to find maps and geographic details in current events, and they'll start doing it naturally too. That's a key component of spatial literacy. That's all for now.